Good morning, students. Welcome back to the chemistry. Come to the lesson periodic classification of elements. The second part. What is the last week you learned the lesson? First one, modern periodic law. The modern periodic table is based upon the electronic configuration of the elements and it depends upon the atomic number. So it states that the physical and chemical properties of elements are the periodic function of their atomic number. The second one, periodic properties. The first one, atomic radius. Atomic radius is the distance between the center of the nucleus and the outermost shell containing the valence electrons. The second one, ionic radius. Ionic radius is defined as the center of the nucleus of the ion and the ion and the electron clouds it exerts the influence of the ion. The third one, ionization energy. It is the minimum energy required to remove an electron from the gaseous atom to form a cation. The fourth one, electron affinity. It is the amount of energy released from the gaseous atom to form an anion. The last one, electronegativity. It is the tendency of an atoms to attract the short pair of electrons towards itself and it forms a covalent molecule. So these are the last week topics. Come to the next topic, metallurgy. Metallurgy is the science of extracting metals from their ores and modifying the metals into alloys for various uses based on their physical and chemical properties and their structural arrangement of atoms. So, metallurgy means the extracting the metals from their ore. What are ores? For example, some of the example, clay, bauxite. So, these are all minerals. And ore means you have to extract the metal from the minerals and that is called as a ore. So, the extracting metals, here you have to extract the aluminium only from bauxite. So, bauxite is the ore of aluminium. Then it forms into alloys. So, two or more metals they combine together to form an alloys and based upon their alloys it is uses. For example, aluminium alloy. Aluminium alloy is used in the scientific apparatus and also aircraft tools, everything. Then copper alloy. It is used in coins, gongs, everything. So, these are the various steps you have to extract the metals from their minerals and also from extracted from their ores. So, these are the pictures you have to see here, the different various steps involved in the extraction of metals. Then metallurgical process involves three main steps as follows. The first one, concentration or separation of the ore. So, here the concentration means the process of removal of impurities from the ore. You have to remove the impurities from the ore. This is the concentration of the ore. The second one, production of the metal. It is the conversion of ore into metal. For example, bauxite into aluminium. The third one, refining of the metal. Refining means it is the purification of the metal. So, a metal contains some impurities. So, you have to remove by an electrolytic refining process. So, it is the refining of the metal. Then, what are the important terms that is used in metallurgy? So, terminology in metallurgy. So, minerals. What are minerals? Mineral is a simple compound or a group of a complex compound that are found under the earth crust. So, minerals, here it is called as a mineral, ore. From the mineral you have to extract the metal and it is called as a ore. For example, clay. Clay has the formula Al2O3.2SiO2.2H2O and bauxite, the molecular formula is Al2O3 dot 2H2O. These two are the minerals of aluminium, but you have to extract aluminium can be profitably extracted only from bauxite. So, bauxite is the ore of aluminium. So, what is the ore of aluminium? Bauxite, the formula, a molecular formula is Al2O3 dot 2H2O. Then what are the differences between minerals and ores? Metals can be extracted from ore, but the metals cannot be extracted from minerals, because a few percentage of metals only present in minerals, but the ore contain a large percentage of metals that is present in the ore. So, all the minerals cannot be called as ores, but all the ores are called as minerals. These are the differences between minerals and ores. The third one, mining. The process of extracting the ore from the earth crust, it is called as mining. The fourth one, the impurities, the rocky impurities that are present in the ore are associated with the ore, it is called as gangue or matrix. Then flux. What is flux? Flux is the substance added to reduce the fusion temperature in order to remove that, it is called as a flux. Then slag. Flux that reacts with gangue to form slag. Slag is a fusible product. So, first you remove the fusible product. The last one is smelting. Smelting is the process of the reduction of roasted metallic oxide into metal in a molten condition. For example, Fe2O3, it reduces to form Fe, iron. So, this process is known as smelting. So, these are the terminology of metallurgy. Then what are the types of ore? First one, oxide ore, bauxite, Al2O3 dot 2H2O, cuprite, Cu2O, hematite, Fe2O3. Then carbonate ores, marble, CaCO3, magnesite, MgCO3, siderite, FeCO3. Then halide ore. Halide means chlorine, bromine, iodine, everything, fluorine. Cryolite, Na3Al(F6), fluorospar, CaF2, rock salt, NaCl. The last one, sulfide ore. Yes, sulfide means yes. Galena, PbS, iron pyrites, FeS2. Then zinc blende, ZnS. Different methods of separation or concentration of the ore. First, you have to concentrate the ore by the following method: hydraulic method or gravity separation method. Second one, magnetic separation method. Third one, froth flotation method. The fourth one, chemical method or leaching. The first one, hydraulic method. It is also called as gravity separation method. Here you have to remove the impurities from the oxide ore. Here the first one, see the diagram. What are the here? The fine particle is there, and you can see water is passing through the grooves. That is a narrow and corrugated. Corrugated means it is a wave-like structure, and it is a gangue particles. The table is there, and here the water molecules are, the lighter particles are move away, and the heavier particles, that is settle down. These are the parts you have in a hydraulic washing method. So, what is the principle? The difference in the density or specific gravity of the ore and the gong, you have to separate it in the main principle in this method. Here oxide ore are purified by hydraulic method. The best example, hematite, Fe2O3, this is the ore of iron. Here the ore is poured over a sloping, vibrating corrugated table with grooves. Corrugated means it is a curve like structure, with grooves means narrow long table, and you pass a jet of water. You have to allow a jet of water, the water flowing is there, is allowed to flow over it, and the denser particle that is settled down in the grooves, and the lighter particles are washed away. Now you separated the ore, and the impurities are washed away. Here you can get the oxide ore, the hematite ore is in a pure form. This is the first method, that is the hydraulic method. The second one, magnetic separation method. Now, what is the principle here means? The magnetic properties of the ores from the basis of separation, whether when either the ore or gangue is magnetic, this method is employed. Here only you have to concentrate the tin ore, SnO2, that is the ore of tin. Here the crushed ore is placed over a conveyor belt which rotates around the two metal wheels. The two wheels are metal wheels. One is magnetic, and the magnetic particles are attracted to the magnetic wheel and it falls separately, and the other are non-magnetic particles that is move away. Here you have to separate the impurities from the tin ore, SnO2. Here again I am explaining here, the crushed ore is placed over a conveyor belt which is rotating at two wheels, metal, it is a metal wheels. One which is magnetic, the magnetic particles are attracted to the magnetic wheel and it is falls separately apart, and the another one is non-magnetic particles, it is move away. In this way you have to separate impurities and the tin ore by magnetic separation method. Then the very important method, the froth flotation method. In this method only you have to concentrate the sulfide ore. The sulfide ore here is a zinc blend. Okay, here this process depends upon the wettability of the ore with the pine oil and the gangue particles by water. Here the sulfide ore can be concentrated by this method. Now come to the diagram. Okay, it's a large tank containing oil and pine oil and water. You can have the compressed air, and here okay, and the sulfur here water containing, the tank containing water and pine oil, and the sulfide ore that come to the surface of the water surface, and the gangue particles that is settled down. Here the fourth bubbles carrying the sulfide ore. So, how to explain means, the crushed ore is taken in a large tank containing a mixture oil and water, and it is agitated with the current of compressed air. Here the ore is wetted by the oil and gets separated from the gangue in the form of a froth. Okay, it's a bubbles like structure. The ore is lighter and it comes on the surface of the froth, and the impurities are left behind and it is settled down at the bottom. Here you have to separate the impurities or gangue from the ore, that is zinc blend. The last one, it is a chemical method. It is also called as leaching. This method is employed when the ore is in a very pure form. It's a very purest form. Okay, it's in by electrolytic refining or any process, zone refining process. The ore is treated with a suitable agent. Here the ore is soluble in water and the impurities are not dissolved. So, it does not dissolve in water. Here you have to separate the impurities removed by filtration, and the solution of the ore, the filtrate is treated with a suitable reagent. Here the precipitate is an bauxite Al2O3.2H2O, the ore of aluminium. Here the ore is separated to alumina. Okay, in this way you have to you have to purify the method by the concentration of the method, the fourth method, chemical method or leaching. Now come to the next topic, that is what are the occurrence of ores that are in Tamilnadu? Here the 6 places, some of the ores present in Tamilnadu. The first one, limestone. Okay, where are the places that present in Coimbatore, Kudalur and Dindigul? The gypsum that is present in Tiruchi and Coimbatore districts. The third one, titanium minerals. It is in Kanyakumari, Tirunelveli and Tuticorin. Okay, in our places. Chromite. Chromite means Coimbatore and Salem district. The next one, magnetite. Magnetite that is present in Dharmaburi, Erode, Salem and Tiruvannamalai districts. The last one, tungsten. Tungsten has the symbol W. It is present in Madurai and Dindigul. These are the ores that are present in Tamil Nadu. Then the properties of metals, physical properties and chemical properties. Okay, in the 9th standard you already studied in the tabulation form. Here the physical state, the first one, most of the metals are solids at room temperature. What are the exceptional here? Mercury and gallium. Mercury, what is the symbol of mercury? Mean Hg. Gallium, Ga. Luster. Most of the metal has the shining in appearance, so that is called as a luster. Metals possess high luster. Okay, it is a metallic luster. Most of the metals are hard and strong. Some of the exceptional here, potassium and sodium. Potassium has the symbol K and sodium has the symbol Na, and it can be cut it with a knife also, so it is very soft. The next one, melting point and boiling point. So usually most metals they have a high melting and boiling point, and it vaporizes at only at a high temperature. Here exception is gallium, mercury, sodium and potassium. The next one, density. Metals have a high density and it has exceptional metals, that is sodium and potassium are very dense than water. The 6th one, ductility. What is the meaning of ductility and malleability? So the metals, they form into sheets and wires. If you are beaten, it forms into sheets and wires. If it is formed into wires, means it is called as a ductility. Metals are usually ductile. In other words, it can be drawn into wires without breaking. Malleability. Malleability means it forms into sheets. Okay, the metal, if you are beaten, it forms into sheets. So metals are usually malleable. They can be beaten into sheets without cracking. Only the exceptional here, zinc and mercury. Then conduction of heat and electricity. Okay. So here most of the metals they conduct, they pass electricity and heat. So most of the metals are good conductors of heat and electricity. The best example is aluminum, silver. Okay. So these are the more the good conductors of electricity, heat and electricity metals. Here the exception is tungsten only. The symbol is W. The solubility, metals, they do not dissolve in liquid solvents. You already know that metals is a solid, so it does not dissolve in a liquid solvents. These are the 9 properties of metals. Then chemical properties of metals. In the modern periodic table, some particular group, they have the same number of valence electrons, metals. Okay, so they have the valency is also the same valency 1, 2 or 3. Here the atoms of metals usually they have the valence electron 1, 2 or 3 in their outermost shell. It has the valency is also 1, 2 or 3. The second one, formation of ions. Metals form positive ions because they lose the electrons, so hence they are called as electropositive. Discharge of ions. Metals are discharged at the cathode. In electrolytic refining process, here the metal is discharged at the cathode. So during the electrolysis process of their compounds. Then fourth one, atomicity. Molecules of metals in their vapor states are usually monoatomic. Metals mean sodium, potassium, calcium, zinc, all these metals are monoatomic. It has the atomicity 1. But you already know that in gaseous atom, chlorine, bromine, iodine, they have the atomicity 2. So that is called as diatomic. Here metals are monoatomic in nature. The last one, nature of oxides. Oxides of metals are usually basic in nature. So, these are the 5 chemical properties of metals. Okay, now you do the assignment. The first one, what is metallurgy? Second one, what are the terms used in metallurgy? The third one, very important, explain froth flotation method with a neat diagram. The fourth one, write the types of ores in a tabulation form. The fifth one, explain the hydraulic method. Okay. Thank you, students.